Welcome to English Through History. If you enjoy the content, then please subscribe or leave us a review. It helps us to create more content and is appreciated by our small team here. We hope you enjoy today's episode. The Tunguska Event, which occurred on the morning of June 30, 1908, remains one of the most mysterious and scientifically intriguing incidents in recorded history. It took place near the Tunguska River in a remote part of Siberia, Russia, and it involved a massive explosion that flattened around 2,000 square kilometers, around 500,000 acres of forest, the size of a large city. So, why is the event so mysterious? Firstly, it was the most powerful impact event ever recorded on Earth, and incredibly, despite the sheer scale of destruction, no impact crater was ever found, and no fragments of any object were discovered, leading scientists to speculate and hypothesize for decades. In today's episode, we will explore the origins, the impact, the scientific explanations, and the significance of the Tunguska event. At around 7:14 a.m. local time, eyewitnesses reported seeing a bright bluish-white light streaking across the sky, followed by a flash that was visible for hundreds of kilometers. Moments later, a shockwave with the power of a large explosion was felt, flattening trees, killing wildlife, and knocking people off their feet as far as 60 kilometers away. People up to hundreds of kilometers away reported hearing a thunderous sound similar to artillery fire. In the nearby Vanavara trading post, 65 kilometers from the epicenter, witnesses said the ground shook, windows shattered, and people were thrown by the force of the explosion. The event took place in a sparsely populated region, which minimized human casualties, although there were reports of injuries among the indigenous Evinki people and Russian settlers. Yet, despite the force of the explosion, there was no visible crater, a puzzling detail that would confound researchers for years. Scientists have estimated that the energy released was roughly equivalent to a 10 to 15 megaton bomb, about 1,000 times the power of the atomic bomb dropped on Hiroshima. The remoteness of the Tunguska region and the limited communication infrastructure of the early 20th century Russia meant that immediate investigations were not conducted. The first detailed expedition to the site didn't occur until 1927, nearly 2 decades after the explosion, and this was led by Soviet scientist Leonid Kulik. Kulik, a mineralogist and an expert in meteorites, was initially drawn by reports of a meteor strike. Upon arrival, however, he and his team found no meteorite fragments or impact crater, only vast swathes of flattened trees, all radiating outward from a central point. Kulik's team documented the devastation and took photographs, which show a forest flattened in a radial pattern around the center of the blast. Trees in the center remained standing, but were stripped of their branches and bark, scorched by intense heat. The absence of a crater combined with this radial pattern led Kulik to hypothesize that the explosion might have been caused by an airburst, in which a meteorite or comet disintegrated in the atmosphere before reaching the ground. Since Kulik's initial investigation, numerous theories have emerged to explain the Tunguska event. Here are the leading scientific explanations. First, the meteorite or asteroid airburst. So this is the most widely accepted hypothesis, and that is that the Tunguska event was caused by a large meteorite or asteroid exploding in the atmosphere before impacting the ground. An object around 50 to 100 meters in diameter, traveling at tens of kilometers per second, would have released an immense amount of energy upon entering Earth's atmosphere. The intense friction and pressure would have caused it to heat up and eventually explode at an altitude of about 5 to 10 kilometers. The shockwave from this explosion would explain the flattened trees and heat damage in the area, while the lack of an impact crater can be attributed to the fact that the object never actually struck the ground. Another plausible explanation is that the object was a fragment of a comet rather than a solid meteorite or asteroid. Comets are composed largely of ice and dust, which could have vaporized entirely upon entering the atmosphere, leaving no solid fragments behind. This theory could also account for the lack of an impact crater and is consistent with eyewitness accounts of a bright blue light in the sky and a blue glow that lingered in the atmosphere after the event. A more unconventional theory proposes that the Tunguska event was the result of a natural gas explosion from the Earth's crust. The theory suggests that large amounts of methane gas might have been accumulated in a pocket below the surface, eventually igniting in a massive explosion. However, this explanation doesn't align as well as the radial pattern of destruction and lacks evidence of any geological precursors that could trigger such an event. Some of the more speculative theories include the possibility that the explosion was caused by antimatter, or even a small black hole passing through Earth. If a small amount of antimatter collided with Earth, it would annihilate with matter in a powerful burst of energy. However, this theory lacks substantial evidence, and there would likely be more specific signatures or residual effects, neither of which have been found in the Tunguska area. Over the years, a range of other explanations have been proposed, from alien encounters to Nikola Tesla's wireless energy experiments. These theories remain largely in the realm of speculation, without substantial scientific evidence to support them. The Tunguska event had a profound environmental impact. The blast flattened an estimated 80 million trees, creating a butterfly-shaped pattern in the forest, with trees lying in a radial pattern. This destruction covered an area of approximately 2,150 square kilometers. Heat from the explosion scorched trees and foliage, causing them to burn from the outside in. Decades later, scientists observed that the soil and the flora in the area exhibited high levels of iridium and other metals typically associated with meteorites. The shockwave and blast also affected the local wildlife. Birds and animals were killed or severely injured, and even in the absence of human casualties, the disruption to the ecosystem was significant. Interestingly, later studies revealed genetic mutations in trees and other flora in the affected region, which scientists speculate could be the result of exposure to radiation or other unknown factors associated with the event. Since Kulig's 1927 expedition, the Tunguska event has been revisited by scientists and researchers from around the world, particularly during the Cold War era, when interest in explosions of this magnitude increased due to nuclear testing. Several Soviet expeditions throughout the mid-20th century continued to examine the site, although no concrete evidence emerged to fully resolve the mystery. In the 1960s, aerial photographs of the region showed more evidence of the explosion's route and impact, yet they still revealed no impact crater or solid fragments. More recently, in the early 2000s, researchers used satellite imaging and computer models to simulate the blast, concluding that a 50-meter asteroid entering Earth's atmosphere at an angle would have caused an airburst similar to the Tunguska explosion. The Tunguska event holds a substantial significance in the fields of astronomy, geology, and environmental science, providing a unique case study in planetary defense against asteroid impacts. The event demonstrated that even without a direct impact, an asteroid or a comet could cause immense damage through an atmospheric explosion. This has influenced space agencies worldwide to invest in monitoring near-Earth objects, NEOs, and developing potential mitigation strategies. Moreover, Tunguska has inspired literature, film, and popular culture, often being depicted as an unexplained phenomenon that fuels interest in space science, meteorology, and planetary defense. The event has also sparked philosophical discussions about humanity's vulnerability to cosmic threats and the importance of understanding our place within the larger solar system. The Tunguska event remains one of the most mysterious natural disasters in recent history, blending scientific intrigue with the elements of folklore and speculation. Although the most widely accepted hypothesis suggests that it was caused by an airburst from an asteroid or comet, the lack of a definitive impact crater or fragments has left room for ongoing debate and research. The event serves as a powerful reminder of the potential threat posed by near-Earth objects and has shaped scientific approaches to monitoring and mitigating similar events in the future.